Okay, today we're going to talk about optimization. So this is an applied field of calculus, very commonly used. One of the most common application in calculus involves the determination of minimums and maximum values. Okay, so what do we mean by that? Well, we're going to start out with something like this. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum value? Okay, well, first of all, we need to get some formulas here. So we've got a box, it's got a square on the bottom, so it's x by x. We don't know what the height is. Okay, but we can figure out a volume formula for this. The volume formula is going to be x times h, which is x squared h. We also know a surface area formula, okay, because the bottom of the box is going to be x squared, and we know that there's four sides, they're all the same, and they're all going to be x times the height. And we know that the surface area has to be 108, so we can go ahead and plug 108 in here. Excuse me. So we now have a primary equation and we have a secondary equation. Now the problem with using the primary equation is we got two variables. So we're going to use the secondary equation to solve for that variable, that extra variable. In this case, it's going to be h. And then we're going to substitute that into this original equation so that we have one equation that's only got x's in it. Okay? So we'll take this formula right here and we'll solve for h. So 108 minus x squared will equal 4xh. And then I divide by 4x, so I'm going to get h is going to equal 108 minus x squared over 4x. And I can take that equation right here and substitute it into this one. So now what we have is we have volume equals x squared times 108 minus x squared over 4x. Okay, now we have an equation that only has x's in it. We can simplify that equation a little bit. So I know that that x is going to cancel out one of those. And so I'm going to end up with v equals 108x minus x cubed over 4. And I can simplify that a little bit. 108 divided by 4 is 27. So this is going to be 27x minus 1/4 x cubed. Okay, now I've got that equation, and I want to minimize or maximize that. So I'm going to find an extrema, which means I'm going to take a derivative. So v prime is going to be 27 minus 3/4 x squared. Okay, then I'm going to set that equal to 0. And I'm going to solve for x. So I'm going to move this over here. So I'm going to end up with 3/4 x squared equals 27. Multiply by 4. Well, let's divide by 3 first. So that'd be 1/4 x squared equals 9. And x squared is going to equal 36, which means x is plus or minus 6. Now, obviously, I can't have a negative distance, so I get to throw out the 6, or the negative 6. Now, don't forget, here's my critical points, right? So, don't forget that critical points are also the endpoints. So what would my endpoints be? Well, the minimum that x could be would be 0. Okay? And the maximum that it could be is the square root of 108 because I have to have part of it here and part of it over here. So I have 3 points that I need to check. Okay, so what I need to find is I need to find the volume at 0, the volume at 6, and the volume at the square root of 108. I don't have to check -6 because I can't have a distance of -6. That doesn't make any sense. So if I plug those back in the volume equation, I get 0. Okay. And I would get this. Let's see here. I'm using this one right here. So when I plug in 6, I'd get 27 times 6 minus 1/4 of 6 cubed. And that comes out to be 108. And then if I put in the square root of 108, that's 27 times the square root of 108 minus 1/4 times 108 cubed, and that also comes out to be 0. So here's my maximum right here. What I want to do is I want to have x be 6. Okay, so once I know that x is 6, I can figure out the height because I can take the 6 and plug it in here. I can take the 6 and plug it in there. And the height is then going to be 108 minus 6 squared over 4 times 6. And that's going to be 108 minus 36 over 24, which is 72 over 24, which is 3. So to maximize the volume of my box, I'm going to have the square base be 6 by 6 inches, and the height's going to be 3, and that's going to maximize the volume of my box. Okay. So, guidelines for solving applied minimum max problems. Identify all the given quantities and quantities to be determined. If possible, make a sketch. That's really important sometimes. Write a primary equation for the quantity that is not maximized or minimized. Reduce the primary equation to one having a single independent variable. This may involve using a secondary equation relating to the independent variables of the primary equation, which is what we did here. We had our primary one, but it had 2 variables, so we had to get a secondary equation that we could solve for that variable, plug it back in, and now we have one equation with one variable. Then we're going to determine the feasible domain of the primary equation. That is, determine the values for which the stated problem makes sense. Okay, so a lot of times you can throw out negative answers. You need to make sure that you use the endpoints as critical points, because a lot of times they're the maximum or minimum. Determine the desired maximum or minimum value by calculus techniques discussed in lessons 3.1 through 3.4. Okay, here we have a graph of y equals 4 minus x squared. It's upside down parabola right here. And what we want to do is we want to find the points on the graph that are closest to the point 0, 2, which is right here. Okay, so since we're talking distance, we're going to use the distance formula. So let's write that down. Distance is the square root of x minus x1 squared plus y minus y1 squared. Now I have a point 0, 2 that I can plug in here for x1, y1. So distance is going to be the square root of x minus 0 squared plus y minus 2 squared. And so distance is going to be the square root of x squared plus, we're just going to leave that as y minus 2 squared like this for now. Now I have a variable, I have 2 different variables, so I have to find a way to get rid of the y in this thing. Okay, so Yeah, this is one of those ones that's a little bit tricky because it's like I don't have a secondary equation anywhere for this. Except I do because I have the equation that I started with right here. Y is equal to 4 minus x squared. So I can take that and plug it in for y right here. And now I'm going to get d equals the square root of x squared plus 4 minus x squared minus 2 squared. Okay, because this is my y right here. Okay, so d equals the square root of x squared plus 2 minus x squared because I combined my 4 and my negative 2. I'll go ahead and multiply this out. X squared, okay, plus 4 minus, let's see, you're probably your best bet is to FOIL this so you don't make any mistakes. Okay, but that's going to be 4x squared plus x to the 4th. And now I can combine my like terms. So d is going to be the square root of x to the 4th. I just move this to the front. Minus 3x squared, so I combine those like terms, plus 4. Okay, now, the next thing I'm going to do is I need to minimize this. Now that I have my equation d in terms of just x, I need to minimize this, which means take the derivative. Now, I could change this to this and find the derivative of that, but that would be a little bit difficult. But think about this. If I minimize the number under the square root, I also minimize the square root of that number, okay? So I don't even need to do this. All I need to do is take the derivative of the inside of this and find its minimum. So d prime of x to the 4th minus 3x squared plus 4 is going to be 4x cubed minus 6x. Okay, that's the only part that I need to do. So I'm going to go ahead and set that equal to 0. I'm going to factor out a 2x. That's going to leave me with 2x squared minus 3. Now this tells me I got a critical point at 0. This tells me that 2x squared is 3 and that x squared is 3 halves, and that x is plus or minus the square root of 3 halves, which is the square root of 3 divided by the square root of 2, which if I rationalize that, that's square root of 6 over 2. Okay, so again, I get to throw out the negative one because it doesn't make any sense. Oh, no, I don't on this one because my graph is going to be both positive and negative. Okay, so I have 3 possible points. I've got square root of 6 over 2, which is going to be like, I don't know, right about here. And I've got negative square root of 6 over 2, which is going to be right about here. And I got 0 in the middle. Okay, so I'm just going to find d of 0. Okay, so if I plug that in here, I get square root of 0 minus 0 plus 4. So that's going to be 2. Distance is 2. I'm going to go ahead and plug in d of square root of 6 over 2. Okay, when I do that, I can go ahead and do that on my calculator. That comes out to be 2.78 approximately. And d of negative square root of 6 over 2 is also 2.78. So, wait, somewhere I made a mistake. D of 0 should come out to be 4. Hang on. Somewhere I have made a mistake, and I need to determine where that is. Okay, found my error here. This is not 2.78. It's 1.32 for both of these. So that's my minimums. And that kind of makes sense, because if you think geometrically, the shortest distance between 2 points is a straight line, and this needs to be a 90-degree angle, which is going to be right about there on both sides. Okay, so there you go, the shortest distance, and then this is a distance of 2, which makes sense because you can just count up the graph. So there you go. Okay, let's move on to the next example. Okay, finding the minimum area. A rectangular page is to contain 24 square inches of print. Okay, the margins at the top and the bottom of the page are to be 1.5 inches. And the margins at the left and right are to be 1 inch. Okay, so we got the drawing here. Here's your writing in here. Okay, here's X. I got a 1.5 inch margin at the top and the bottom. Here's Y. I've got a 1 inch margin on each side. What should the dimensions of the page be so that the least amount of paper is used? So I want to minimize the area of the paper. Okay, so I need a formula. Area is length times width. So in this case, it's going to be X plus 3 times Y plus 2. Okay. Now, I also need a secondary equation, and I know that the area is going to contain 24 square inches of print. So the print is the X and the Y. That doesn't include the margins, right? So my secondary equation is going to be X times Y has to equal 24. Okay, so I'm going to go ahead and solve for Y. Y is going to be 24 over X. And now I can substitute that into this equation here. Area is going to be X plus 3 times 24 over X plus 2. And it would be really helpful to multiply that out. And so I go ahead and FOIL that. And this comes out to be 30 plus 2x plus 72 over x. Which I'm going to go ahead and write it as 30 plus 2x plus 72x to the negative 1 power. Because since we want to minimize the area of that, we're going to take the derivative of a. So the derivative a prime is going to be 2 minus 72x to the negative 2 power, which will be 2 minus 72 over x squared. Okay, now we would set that equal to 0. Set that equal to 0. Now, when this is going to be 2 minus 2 would equal 0. So if this would be 2, the bottom would be 36, which means x squared would be plus or minus 6. Now, again, I can throw out negative 6 because I'm talking distance, and so the 6 doesn't really count. Okay. That also tells me let's see, I need to find the areas. And I need to check, let's see. I need to know what my domain is going to be of this. So I could make x equal to 0. But if I did that, I would have 0 times, the area would be 0 times whatever, would not ever equal 24. So the only place I really need to check here is 6. Okay, 6 is going to be my minimum. And if I take the 6 and I plug it into here, I get 6y equals 24, and so y would be 4. Now, be careful that you don't put down 6 and 4 as your answer, because remember, the dimensions of the page are x plus 3 and y plus 2. So if my x is 6, 6 plus 3 is 9, so my page is going to be 9 inches by 4 plus 2 is going to be 6 inches. And that's going to be the area that's going to minimize that amount of paper. Okay. Let's go on to example 4. Finding a minimum length. So in this picture, I have 2 posts. One is 12 feet high. The other is 28 feet high. They stand 30 feet apart. Okay. They are to be stayed by 2 wires attached to a single stake. So there's going to be a single stake somewhere in the middle here that I'm going to attach guide wires to, okay, to the top of those posts. And the question is, where should the stake be placed to use the least amount of wire? So I've gone ahead and drawn a picture. It's going to be somewhere between these two. Okay, so I don't know where it is. I know this is 30 feet, so we'll say this is x, and that makes this 30 minus x over here. I don't know what this is, so I'm going to call it y, and I don't know what that is, so I'm going to call it z. Now, I do know that w equals y plus z. Okay, that's the amount of wire that I want to use. W is y plus z. Okay, now I want to get these down to a single variable. I don't want to use y, and I don't want to use z, so I'm going to turn it into an x. Now, there's going to be a lot of algebra in this problem. Okay, so the first thing I know is I'm going to use the Pythagorean theorem on this because these are right triangles. Okay, so I know that x squared, oops, thought I got a red pen, x squared plus 12 squared equals y squared. And I know that 30 minus x squared plus 28 squared equals z squared by the Pythagorean theorem. Okay, so then if I take this one and I solve for y, y is going to be the square root of x squared plus 144. Okay, this one over here is not going to be quite as easy. I'm going to go ahead and multiply this out. So this is going to be 30 times 30 would be 900 minus 60x plus x squared plus 28 squared. 28 squared is 784. That equals z squared. Okay, and then I combine my like terms, so I get x squared minus 60x plus 1684 equals z squared. And so z is the square root of that. Okay. It's kind of hard to read. So now I know that w is going to be y plus z. Okay, that's what I want to minimize. So let's go ahead and rewrite this. This is x squared plus 144 to the 1/2 plus x squared minus 60x plus 1684 to the 1/2. And I take the derivative. So this is going to be 1/2 times x squared plus 144 to to the negative 1/2 times 2x by the chain rule plus 1/2 times x squared minus 60x plus 1684 to the negative 1/2 times 2x minus 60. All right, not horrible so far, but we need to do some cleaning up here. So I can do this. This 1/2 is going to cancel that 2. And this 1/2 here, we can cancel a 2 and the 60 and make that 30. And so W prime is going to be x over the square root of x squared plus 144 plus x minus 30 over the square root of x squared minus 60x plus 1684. Okay, there's my derivative, which we want to set equal to 0. Here, let's use this. Okay, so if I move this over here, I'm going to get x over the square root of x squared plus 144 is going to equal negative x minus 30 over x squared minus 60x plus 1684. And you know what I could do is I can distribute that minus sign in the top here. Let's just do that right now. And we're going to make that 30, positive 30 minus x instead. Okay, now this is a proportion is all it is. So you solve a proportion by the means extremes. I'm going to multiply these two together, and that's going to equal those two multiplied together. So x times the square root of x squared minus 60x plus 1684 is going to equal 30 minus x times the square root of x squared plus 144. Okay. Now I got to solve for x, which is not going to be easy here, but I think it's going to be simpler if we square both sides of this equation to get rid of all the square roots. So this is going to be x squared times x squared minus 60x plus 1684. And this side is going to be 30 minus x squared times x squared plus 144. Okay, so now I can kind of clean this up, and there's a lot of algebra here. So this side is going to be x to the 4th minus 60x cubed plus 1684x. This side over here, okay, I guess I'll do this in baby steps for you. I'm going to square this. That's going to be 30 times 30 is 900 minus 60x plus x squared times x squared plus 144. And if you want, you can use the box method or whatever to solve this. This is going to come out to be x to the 4th minus 60x cubed plus 1044 x squared minus 8640x plus 129,600. And this side we'll just bring it down. Okay. So, whoops, I got a squared here. This is a squared. All right, so let's combine our like terms. We can subtract x to the 4th from both sides. we can add 60x cubed to both sides. So this goes away, this goes away, and I end up with 640x squared, if I subtract this over here, plus 8640x minus 129,600 equals 0. Okay, now you might not notice this, but you can factor out a 320 on both of these. Gives you 2x squared. Gives you 432x. Let me double check that. 8640 divided by 320. Nope, not 8640 divided by 320. Well, that's 27. And 129,600 divided by 320 is 405. Okay, so I could ignore the 320. Now, if you factor this, this actually comes out to be x minus 9 times 2x plus 45 equals 0. And then you can solve for both of these. X comes out to be 9. X comes out to be negative 22.5. I don't need this answer. It's extraneous because it's negative, and that's a distance that we're talking about here. So, okay, so now I'm going to find the endpoints. So the endpoints would be 0. Obviously, I could make x a minimum of 0, and I could make the stake go all the way over to here. Or I could make it 30 and have this stake go all the way over to here. So those are my endpoints, plus I've got 9, so I'm going to find W of 0, I'm going to find W of 9, and I'm going to find W of 30. Okay, so if I plug those into W, I get 53.04 for this one, I get 50 for this one, and I get 60.31 for this one, and that tells me that the minimum is right here. So I should stake this thing 9 feet away from, I should make x 9, so it should be 9 feet away from the 12-foot pole right there. And that minimizes my, it minimizes this distance right here. Okay, an endpoint maximum. So 4 feet of wire is to be used to make a square and a circle. Okay, how much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area? Okay, well, first thing is I got to come up with a formula for area. So the area is going to be the area of a square, which is going to be x squared, because I don't know what the side length is, so it's just x, plus the area of a circle, which is going to be pi r squared. Now I've got two variables here. I've got x and r. I have to find some other way to get rid of one of those variables. It's going to be the r that we're going to get rid of. Okay. So here's what I do know. If I know that a circle has a radius of r, I know the circumference is 2 pi r, and I know that the circumference of a square with a side of x is, or not the circumference, but the perimeter is 4x. And I know that I only have 4 feet of wire. So I know that I can write another equation, a perimeter. The perimeter is going to be 4x plus 2 pi r, and I know that perimeter is going to be 4. So here's my other equation. Now I can solve for r, and I can substitute it in here and get rid of the r's. Okay, so 4 minus 4x equals 2 pi r. And then r is going to be 4 minus 4x divided by 2 pi. And I can cancel a 2 because there's 2's up in here. So that would be 2 minus 2x over pi. Okay, so I'm going to take that. In fact, I could rewrite that as 2 times 1 minus x over pi. I can take this and substitute it in here for r. And now I'm going to get a new area equation. Area is going to be x squared plus pi times 2 times 1 minus x over pi squared. Okay, so I'm going to go ahead and square this and kind of clean up this side here. Nothing's going to affect the x squared. Now this is going to be pi squared on the bottom times a pi on the top, so that's just going to be a pi. Let's see, I square the top, it's going to be 4 times 1 minus x squared like that. Okay, so whoops, there's a plus right here. That's what the problem is. Okay, now I think I'll rewrite this a little differently. I call it x squared plus 4 over pi, because that's just a constant, times 1 minus x squared like that. Okay, now I got to take the derivative of this thing. So can I clean that up a little bit? Well, let's take the derivative and see what we get here. So the area, the derivative of this would be 2x plus, this would be 8 over pi times 1 minus x to the first power times negative 1, because that's the derivative of the inside. So this would be 2x minus 8 over pi times 1 minus x. Okay, so I would have to set that equal to 0. Okay, so let's see. 2x minus 8 over pi minus 8 over pi x. If I distribute that, would equal 0. 2x minus 8 over pi x would equal 8 over pi if I move this 8 over pi to the other side. If I factor out an x, I get 2 minus 8 over pi. And now that's a constant, so I can divide that over there. And I'm going to get out my calculator at this point and figure out what that is. Okay, so 8 divided by pi divided by 2 minus 8 divided by pi. Let's see. That's not what I wanted. All right, hold on right here. Let me figure out where I've made my mistake. Okay, found my mistake here. It was right in here. So when I did this line right here, I distributed this and this at the same time. So 8 pi would go here, but it would be negative, which I did. But then when I distributed this over here, I didn't distribute the negative, so this should have been positive. Okay, so that makes the difference in the problem. This is positive right here. This is positive right here. This is positive right here. And that means that this comes out to be 0.56. Okay. Now, again, your endpoints, what are your possible endpoints with this? Well, if we look at the square, the minimum I could make a side would be 0, which would mean the circle would be the entire thing. There would be no square. The biggest I could make x would be 1, because remember the perimeter is 4x, and so 4 times 1 would be 4, and that's all. I only have 4 feet of wire, so that's it. Okay, so my endpoints are also critical points. I've got to include 0 and 1. Okay, so I find a of 0. I find a of 0.56, and I find a of 1. Remember, I'm using the original equation to find this stuff. So if I plug in 0 into my original equation with just x's, okay, I'm going to get 0 plus 4 over pi times 1 squared. So it's just going to be 4 divided by pi. 1.27. We'll go 1.273. If I plug in 0.56 into that equation, it comes out to be 0.56. If I plug in 1 into that equation, it actually comes out to be 1. So what does this tell me? This tells me this is my max right here. Okay, where x is 0. This would actually be my minimum. Okay, but I want to maximize the area. Okay, now let's think about why would I want to do that? Well, what shape has the maximum area for its perimeter? And that's a circle. Okay, anything that I add a square is pretty good. It's the second best thing behind the circle. Okay, so or at least as far as rectangles go. So any time I add anything to the square, that's going to reduce my total area because it reduces it from the most efficient thing, which is a circle. Okay, so what I want to do is I don't want to make a square at all. To maximize my area, I just want to make a big circle as big as I can with all 4 feet of wire. Okay, I've only got 7 problems for you to do, so take a look at that. And I will see you next time. I will send you a review for asynchronous time. And if you got questions, you better hit me up during asynchronous time because our next class will be a test. Have a good time, a good day.